Hello and welcome to DCG's development update. We are here with the core, the platform, and the mobile teams. And today, in hopefully under 60 minutes, we can give you a presentation about the progress of the past 2 weeks. If you have any questions, please, or any comments or feedbacks, drop us a line in the live chat below. If you have a question that you would like to address to the Q&A session at the very end, please use a Q prefix. Please use your Q prefix so we'll know that it is intended to the Q&A session. All right, without further ado, let's start with the platform teams.
Sure, I'll start. As people can see, I decided to come and find Ivan to make sure that he was working extremely hard these last 2 weeks. And he has. Well, I haven't been here for 2 weeks yet, but we have some excellent news to share today on achievements that we've made, especially around the multi-threaded platform and the load testing that was done. That was the main focus over the last 2 weeks for the majority of the team. And yeah, we really did very well there. On top of that, there were other tasks that I took, that Igor took in platform, and Paul continued with strategies. The real goal is that when we get this multi-threaded platform, then we're going to start running all these different strategies and basically Paul's work against it. And when we get the multi-threaded platform, like we have it. So then Evgeny was on holiday a lot of this sprint, but he also worked on the platform TUI. And because we're pretty advanced in the project, there has been this idea that towards the end we would do a code review. Everybody would do a code review, and I started on that in the last 2 weeks as well. Okay, let's move on. And Lukasz, why don't you start?
Yeah, hi. So basically, I will tell a bit more about platform stress testing and load testing that we are working on, mainly from TenderDash perspective. Then Ivan will add something from the Drive perspective. What we are doing, we are sending some documents, random documents, to 10 master nodes on our DevNet with some tool that we wrote. Mainly Ivan. So basically, it's just generating tons of random documents and sending them to the system, right? These documents need to be processed, including the block. Basically, this is the whole test scenario. So to get stable results and also to fix performance issues, we did multiple changes in TenderDash. Part of that was already described in more details during previous calls, so I will not get into details here. However, one of the items where we order requests between TenderDash and Drive based on some priority of these requests that we decided like consensus messages are more important than queries. So that logic was added, but we will revert that because we went into a bit different direction, which I'm sure Ivan will tell more about. It's about multi-threading. So basically all these changes here are just in testing right now, and the ones that are displayed are basically need to be stabilized, cleaned up, maybe some unit tests or other automated tests added and merged. So this work in progress that is in testing or is just pending that. Can I get the next slide? Yeah, here are other tasks like this. So from what needs to be mentioned here is that we added some rate limiting for a transaction broadcast. So when you send a transaction to a mempool of one node, it's sending it through some gossip protocol to all other nodes in the network. However, if you have tons of transactions on the network, like in our case, when we are running our tests, and we need to limit it a bit. So we are doing rate limiting here, and we are also defining timeouts so that sometimes a person who sends a transaction can just get a timeout right now if the node is overloaded. Previously, we were just not able to process all that information, and the consensus was stopped, like the node stopped voting on new blocks. It was a big issue. Right now, we just limit the rate and limit time of processing of these messages. We also did some fixes and bindings for Tender Dash. So another major thing worth mentioning is that we added gRPC protocol between Tender Dash and Drive, because that gives us quite big improvement in terms of multi-threading environment, which Drive, thanks to mainly Ivan's work, right now supports. Yeah, and Ivan, do you want to tell more about this?
Yeah, sure.
Yeah, so let's go to next slide.
We are talking about it for a couple sprints already. It was huge work, and so basically to understand what was done, we need to remind ourselves what was how Drive processed the messages initially, the carbon, like yesterday, I would say. So Tender Dash is implementing ABCI protocol to that's providing by Tender Dash and handles it's several messages with different purpose, and Drive process these messages sequentially. There are, I would say, two types of messages, like if you want to simplify things. The first type of messages is the consensus messages that are critical for the block production process. And other two messages are, I would say, it's more like can be considered as read-only. And first of them is query. It's just to provide the state, what the blocks are creating. And the second one is check TX. It's to verify transaction before it gets into mempool. So the both are not changing the state, they only reading it. And since consensus messages must be sequential, they can be done one after another. They must be done because first you do prepare a proposal, and proposer proposing the block, then other validators receive the block, they voting for this block, and then they do prepare a proposal and editing what extensions, and then finalize block. So the consensus polka, it's always the sequential circle of steps. And the problem what we faced that since we used one socket connection between Tender Dash and I think it's still somehow implemented in Tendermint as well. So you have one socket connection where messages are processed sequentially after one after another. So it means even if there are some user-generated messages not related to consensus, I mean queries, like when the users reading the data, and check text when user broadcasting the transactions to the network to write the data. It creates like tons of messages that we need to process, and those messages, they basically delayed the messages of block production and interfere the process. That was the bottleneck what we faced last time, and so we did like some experiment, different approaches. We discussed it last time. So, and today we will talk about the final implementation, what we have done. So there are, you may see the list of some improvements. I don't like spend time on them. So the most important here is that we were able, thanks to new TenderDash routed ABCI client, now we can specify in Drive like, oh, I want TenderDash for the query go with gRPC to Drive, and for consensus go with still with the socket, because for consensus we want to process them sequentially, because there is nothing like, you won't gain anything, no benefits trying, you know, to do some like concurrency there. And for query and for checktx, we built a separate server in Drive that listen for gRPC connection. It serves the HTTP too, and yeah, and it's processed like this Tokyo runtime. It's processed in parallel with consensus server, what we're still handling as well. What important points is that the multi-threaded and asynchronous, it's slightly different things in Drive. So we still have synchronous code. So the logic where we doing checktx, the all shared logs for the state and other primitives, they are still synchronous. It doesn't allow us to completely use Tokyo runtime and do like asynchronous stuff, which is very efficient when your code is yielding and switching between the tasks. So too much technical, right?
Very too much technical.
Okay. So
let me say one thing. The goal of all of this work that we've been doing, is when we bombard platform with state transitions, platform doesn't go down. And now we bombard with state transition, and does platform go down?
No.
Exactly. That's what people want to know. This has been a monumental achievement.
Thank you, Sam.
No problem. This has been a monumental achievement. And I think like you talking about gRPC, people are not really going to understand that it was a monumental achievement.
Yeah, thanks. So yeah, and like just summarizing, the queries that to reading the state, they before went through like DAPI, then TenderDash, then like through no, actually not the DAPI, the client sent to a proxy server to Envoy, then to DAPI, then through the ABCI protocol to TenderDash, then to Drive, and back and forth with all this serialization, decoding, and it was super inefficient. And we are now routing all the messages directly to Drive, which makes it much faster. And
I'm here to translate. The queries are now faster.
And do not interfere with consensus.
And do not interfere with consensus. Much better. And this massive amount of work that was on all of our consciousness was merged in today. It was
Yeah.
merged in about an
See
hour ago.
what it did with me.
Yeah.
I'm not a human anymore. So,
One of the reasons why I'm here is so me and Ivan could work together and finish this, and we did. So, I mean, there's still stuff in progress. There's still a few little items to try out, but yeah,
yeah,
big achievements here.
I also noticed that. So there is some improvements that we still want to do. We want to limit the incoming requests, but we need to do more tests to figure out what numbers should be. And there is some optimizations, what we can do for the shared logs for the state. It is not super great right now. I also, the last thing, to visualize all this process, what is going on inside the drive, we introduced the Tokyo console. It's debug interface, what you can use in the console to see like all the tasks, what happening inside. And I will show you really quick. So just to see the difference. Oh, I want to share my screen. Yeah. Should I do it?
Do it. It's kind of cool. Looks a little bit like the Matrix.
Yeah. So this like, why is not here? Okay, cool. So this is console connected from my local machine to the one of the nodes on our DevNet also. So just previously it was one line here. So now you see many lines. It means like many stuff is happening in parallel, and you can see the rechecks, check TX. Currently, we're not sending queries, so you don't see it. But basically, we can see that we are doing stuff in parallel at the moment, and overall performance grew.
Yeah, so right now we're sending a lot of transactions to this network, and what we can see is, it's handling a lot of stuff at once, right?
Yep. And there is no like the deadlocks and stuff.
And the system is still advancing, no problem. Yeah. So when we think about optimizations, like where can we go from here? Well, we've already achieved what we want to achieve. The system goes and doesn't stop. But there are some small things that we can do to probably have a much higher transactions per second. But we're really going to be limiting that over. I mean, the real focus is to release, not to have a high transactions per second. But we are going to be, seeing if there's any very small things that can improve things for us. And with that, I think, are we done?
Yeah.
Do we pass it back to Lucas?
Not yet.
Not yet. Okay.
Balázs will share, yeah, the slides.
Yeah, I'm on it. Give me a second.
I just wondering what you did before, like this demonstrating before.
No, I'm here for you. I'm here to like make you to summarize for our audience.
Yeah, that's great. Yeah, let's switch to the next slide, and Lucas tell us more about the stress testing process.
Yeah, I will show you how we test, how we analyze the results of our tests that we are running. So basically what we have is a 10 Evo master nodes network on AWS. Each master node has 4 CPU cores and 16 gigabytes of memory. That's basically what we published as a recommended configuration for a master node, at least in terms of CPUs.
Evo node, for an Evo node.
Yeah, sorry, yeah, for Evo master nodes. And we have disabled rate limiting in terms of when you will send messages to platform, we will have a rate limit and mechanism that will limit amount of requests you can send per second or per minute. Not sure right now how we'll finally tune that. But we have disabled these limits so that we can actually test various high load scenarios, right? So our scenarios are just creating random documents. It's between 50 and 400 random documents per second. So we are testing for these various numbers like 15, 100, and so on, up to 400. As a tool set, we use Elasticsearch and Metric Beat, which are parts of the Elastic Stack. Elasticsearch stores logs and stores parts of metrics, and also Metric Beat is part of that stack that is processing these metrics and making it all work. As metrics, I understand stuff like how much CPU we use, which Docker container uses how much CPU, how much memory, all that information. When it comes to Tender Dash processing statistics and metrics, we take that from Prometheus exporter that is part of Tender Dash. So we also have a Prometheus instance deployed on that development environment. Maybe in future we will migrate it to only have Elastic Stack and remove that separate Prometheus, because there's a plugin for Metric Beat that can just interpret Prometheus exporter statistics. But yeah, for now, this is what we use. And the last tool that is really useful is Grafana, which we use to show some charts. And I would like to share my screen and show you that Grafana, how it works, how it looks like, and how it's a bit simplified approach, but more or less how we work with it. Do you see Grafana?
Yes.
Okay, so basically we have two scenarios. So first one is where we send 50 documents per second, and second one where we send 400 documents per second, right? So basically, after we execute that test, we run it for at least 10 minutes to just have all the statistics quite stabilized. And here you can see the charts that are displaying this 50 documents per second effort, right? Here from top to bottom, we have mempool size, so how many transactions are waiting to be included in the block. Then we see how many blocks per minute are mined. And then we see how many transactions per second we mine. And then we can see how many transactions are in one block, right? So these are, I think, the basic parameters that we are interested in. And about colors of lines, so the line that is green is 1 minute average. So we calculate average, for example, blocks per minute over 1 minute average. And second one is per 5 minute average. So basically it's more smooth and a bit better to get good understanding what's happening in the system, right? So as you see here at about, I don't know, 13:25 or 20:26, the test starts. And some transactions start to build in the mempool of this master node. One more thing, this is for master node 1. We analyze statistics from one master node. Of course, this tool supports all our master nodes. So if there is anything we want to investigate, we can switch to another one. So basically here we see that the mempool grows, and because this master node is not the proposer, it's not the host that is generating the new block, it's just voting for the block. But at some point, this host becomes the proposer, so it can propose its own block. So at this point, we can see the drop in number of transactions, right? And that block is generated and processed there then. And in terms of performance, this is where we create 50 documents per second, and we can see that at the beginning we have like 50 blocks per minute. These are blocks per minute, but with 0 transactions. So We just do an empty block every some time. That's how we have our system configured. But as the load grows, this blocks per minute metric just drops down up to like 30 blocks per minute, right? But these blocks already contain like 50 transactions per second or 123 transactions per block. So each block has more or less 100 transactions. There is some peak where we got full block. 1400 is our limit of transactions, but besides these peaks, the average is like 100 transactions per block for this test conditions. And once the mempool is the test finishes after like 10 minutes, network starts to mine blocks faster and recovers to normal speed of 50 blocks per minute. So this is what happens for 50 transactions. More interesting case is what happens if we just send 400 transactions or 400 documents per second. So in this case, our mempool becomes full very, very quick, right? So within, let's say, 4 minutes or so, we have a full mempool. So all new documents will be rejected because the mempool is full and all transactions are of the same type, like create document. So all these transactions have the same priority. So we reject them if the mempool is full. And this is the case where we had serious issues with performance because multiple nodes were just gossiping their transactions. One more thing to add here is that each node gets its own unique set of documents. So if a mempool is full on all nodes, each of them tries to gossip its transactions to other nodes. But the other node already has a full mempool, right? So basically that gossip fails. And it was an issue previously before our fixes because it was able just to overload the connection between two nodes and do a denial of service in terms of consensus voting. So the node was so loaded with mempool transaction gossip that it wasn't able to vote for blocks and the network was stopping. We fixed that, and right now, as you see, the mempool is full for some time, but still something happens in terms of blocks per minute grow significantly, but they are still like producing blocks like 3 blocks per second per minute, sorry. So the chain is not halt, it's still producing blocks. Once the mempool is less full, this 1 minute average is just growing, right? We see that we even get to 40, 50 blocks per minute, and then it's stabilized on the same 52 blocks per minute as previously. In terms of transactions, when we are on a full load, we have an average of, I think, 1400, which is our maximum block size we have set. So 1400 transactions per block. And the most interesting metric, which is how many transactions per second we can process, is right now at 90 transactions per second. So the network with full load, with full mempool, is able to process 90 transactions per second right now. And with some changes we are still working on, we plan to further increase that over time. As some already mentioned, it's not our goal per se, but yeah, we are doing our best to get better results right here.
Sorry to interrupt you. Can I ask what
Yeah.
network this test was performed on?
Can you repeat? Sorry.
Can you say what network this test was performed on?
Yeah, it's on 10 master nodes, each with 4 CPUs and 16 gigabytes of memory.
And network was Uzo.
Yeah, it's our internal DevNet.
Yeah.
Yeah, so I think that's pretty much it on my side. We of course have much more, or maybe one interesting metric that I can share about the network. So the memory usage is for that test at like 10%, so not so big. And Docker or CPU usage is the yellow line here is just 80%. So we don't reach 80% of CPU usage, more or less. So I would say CPU is not a blocker for us in terms of getting better performance, but we still need to work on that.
Yeah, I
So
would
that,
like that. Oh, well, actually, let me know when you're done. I'll add a few things.
yeah, I'm done with that demo. So if there are any questions, feel free to ask on YouTube.
Yeah, I just want to tell people that the goal here was not to get a high transactions per second. That was not what we were trying to achieve. What we were trying to achieve was the system to be stable against a very high amount of transactions per second. We've never achieved that before. Like every single time platform would go down, and now it no longer goes down. And our first result that we see from it not going down is 90 transactions per second. I think that's not bad for a first non-optimized, like we have not even looked at why are we only getting 90 transactions per second, right? We see that the CPU is not the bottleneck, that the memory is not the bottleneck. We could be facing like small little things that drastically improve the transactions per second, since what we would expect is the CPU to be the bottleneck when we actually get there. But we're currently not seeing that. So I do think that within a few weeks, we're gonna have a different transactions per second. It's
Yeah,
not a promise, but I do think that with a little bit of, when we start looking at, okay, well, what's holding us back, we're gonna find a few things that will really improve those numbers. As well as, I do want to also point out that this is running only on a 4 CPU machine. So the amount of for CPU, 16 gigabytes memory, that is powerful. Validators on some other networks, they're 10 times that, and they ask for 10 times that in power. So what we do see is, even right now, our system does seem to be quite efficient, and that's very nice.
Yeah, I can just add to that two things. First of all, here on the blocks per minute, we see it's stable and it's recovering from this load, getting back to 52 operations per minute, right? So 52 blocks per minute. So what Sam just said, that we are stable, we are not breaking the platform under load, is definitely, you can see it here basically, right? So we start with some performance, and we then, after processing everything, when the block is empty, we have the same performance. And second thing to add, maybe a bit geeky, but basically we have all these histogram diagrams that show us which request sent between tender dash and drive is slow and how much time it takes. So like here, we can just take one of these charts, investigate what's happening there, why it's getting to 25, for example, and then fix that and select another one, and repeat and repeat. So we have, it's basically a starting point right now, right? So we have some more topics to do. We have tools that show us where to focus, to not spend time optimizing, I don't know, in this case, for example, extend vote, which is quite fast, right? But just go to check why Flash doesn't work fast enough. So why it's like up on so long, right? These numbers are just seconds of processing of individual requests. So we got some very, very high flash operation, and now we need to investigate why, because this operation should not take so long. And yeah, that's a repeating process of finding the biggest bottleneck, optimizing it, and getting new results and going in circles like that.
Yeah, but I do want to say that we're not going to, we are going to go to mainnet with a system that we're not going to try to get 1,000 transactions per second before we go to mainnet.
Yeah,
We
sure.
are
Yeah, let's
going
go
to
back.
put some effort into it for a few weeks, just because it is going to, vastly improve the system, efficiency of the system. So we don't want to just, oh, okay, the first thing that works, we go with it. We're going to do a little bit of, check what needs to be fixed.
Low hanging fruit.
Yeah, the really low hanging fruit, right? Because we could probably, I don't want to make any promises here, but I'm sure we can get, I'm not sure. I'm not sure. We can probably
I'll make
get 200 transactions per second. Also, one other thing to note here is that these aren't, on a lot of networks, you're going to see like state transitions per second, et cetera. It really depends on the contents, right? So right now, what we're inserting are documents for this test. And these documents aren't the minimum documents. We actually are inserting like a document that does have secondary indexes
Unique.
and unique. And it's not the fastest one we could show, but it is more realistic towards what we would see when we go to mainnet. We don't want to put some numbers out there with the most easy thing that exists, and then when it comes out, we only actually see like half of that, right? So just pointing that out as well. Okay.
All right, Sam, I'm
Let's
going to
move
ask
on.
the question that I'm sure everyone in YouTube wants to know. Is there a timeline to reproduce this test on testnet?
A timeline to reproduce this test on testnet. Yes. So what we're going to do, this actually was done against a version that's, a week old. Doesn't sound like much, but it's an eternity. We just merged in.
It didn't have some improvements.
We already have quite a lot of improvements that we're very, well, I'm very eager to test against, right? Because, there was a lot of work in the identity contract nonces that was merged in a while ago that is actually not in these tests. So today we merged everything together, but we didn't have time to run the tests against it because we finished that work probably like 2 hours ago, maybe even less. So when the first goal is to update Uzo with these with the new code that we just finished, see what the numbers are there, and then we're gonna release a new version to testnet, and then we're gonna start testing on testnet instead of Uzo. And we'll give you those results in 2 weeks.
Since network survives, we can start kill testnet now.
Yeah. And the next big goal that we have is to, as I talked about strategy tests, is to basically tell the network and you guys, not the network, you guys, basically our community, start attacking it. Think of ideas of things that you want to try to test, and then you can, if you have a little bit tech savvy, you can create a strategy, and then you can run the strategy against testnet, and try not to run the strategy at the same time as 5 other people are running their strategies, but you can try. Everything, it just will probably be a little bit slower, but the point is that nothing should take down the network once we get it to that stage. And we are really going to try to get to that stage this month. Basically, like I have a hardened network. And that's like when we think about where we were a few months ago or a few years ago, yeah, having a network that won't go down is really like the biggest, the thing that we want. I mean, it still will go down, right? Like when we go there, there will be a bug, there will be another bug, but you know, once we pass those 2 bugs, hopefully, yeah, it will be ready for mainnet.
Alrighty. Shall we give it back to Łukasz?
Yeah, just two charts that show how many transactions we can mine depending on the load. So from our tests, we get up to almost 100 transactions per second with 100 documents per second. And later on, it gets a bit slower, but it's stable at 85 transactions per second on our tests. And in terms of blocks per minute, we get to 3.6 to 3.4 to 3.6 blocks per minute. So it's also getting stable at some point after 200 documents per second. And yeah, that's just to comment on that. And on the next slide, we have some summary, I think. Yeah, so some other low-hanging fruits we see is that first of all, TenderDash has high CPU utilization even without cloud. So most likely there's some easy place to optimize that further. We noticed that we have quite low memory usage. Of course, we don't have too much data in the system for that test, so it can change. But at this point, I checked today, it was like 2 GB of memory used on the test network node. So it's really not memory critical. It's much more about CPU. Yeah.
It doesn't mean we will add more cache or stuff in the future, right? To utilize it more.
Yeah, I'm just talking about our intermediate results as we have right now, and it's, of course, you can imagine various different test scenarios than just including inserting a document, right? So yeah, that's a good like information here, and that we need to address to also run other types of tests. Yeah, as we already mentioned, we are not able to kill the network right now. It's still producing blocks. Just the amount of blocks is much slower, but the blocks are much bigger, right? But the network is stable. Yeah, and next bottleneck to handle is block processing in Drive. So we will see if there is something we can easily improve in Drive ABCI. In terms of how fast we process the block, because that's what we found out to be next bottleneck. As I already mentioned about our approach, we find the bad bottlenecks, then we fix the biggest bottlenecks, and we get really good results thanks to this process. So I think that's it about the platform stress testing. So let's go forward to identity analysis.
Oh yeah, some other tasks that we worked on, and we're going to go over these quickly. So something that I've also been working on is the review of the code base. Basically going through most of the code to check to see if there's any problems and think of any ways to attack the system. And one of that, I did find one for data contract create, and I found a few more that I'm going to be fixing over the coming weeks. Theoretical, well, they're not just theoretical attacks. I could definitely make them. And they're not even hard to do. So, I mean, what would happen if I were to perform these attacks? Well, it would be most likely that the system would just slow down. It wouldn't even break, but we don't want an attacker to be able to slow down the system so much. And with without paying for it, right? So the thing that we have to stop is that somebody does some operations to the network and they pay almost no money, but the network just goes very slow. And yeah. So I added an identity nonce for data contract. We had previously added identity nonces for identity operations and identity contract nonces for data contract update and document changes. And yeah, so now this is added. Just for developers out there, we use the identity nonce instead of entropy now for the contract ID uniqueness. This, I mean, won't go into why, but it basically is a small change, so developers out there might notice it. I also added a put contract call to the Rust SDK that was missing. Before, people had to do a manual call to add a contract. Now it's more straightforward. Another thing that I did that I just realized that we were missing is in the fetch calls from platform, you would just get back the data, right? So if you said, hey, I want a document with this ID, it would just give it back to you, and it would, the SDK would just give it back to you after it was proved, right? But it wouldn't give you any metadata around it, like, oh, what's the current block height? Or all of this data actually comes back with the proof. So sometimes you might want to query platform and you might want to know a little bit about the state of platform because it's already given back to you for free. So why not be able to use it as a developer? So I just added fetch, I think it's called fetch with metadata, and it basically gives you back, I think the current epoch, the current block time, yeah, block height,
core height,
and core height. Yeah, thanks. He helps me now. Okay, yeah. So those are some extra tasks that I did. Let's move on.
Let's move on with Igor.
Hey everyone, thanks for having me. So this week I worked primarily on the maintenance and bug fixes and tests. So here is the list of what we managed to accomplish. We fixed skipped masternode identities tests. We fixed a bunch of skipped DPNS tests. We removed obsolete masternode reward shares tests, since the use case they were testing is not supported by the system anymore. And also we added the tests for the withdrawal notifications. So basically, there were not much bugs in the system itself. Those tests were just skipped right after we finished with the refactoring of the drive with Rust. And many things weren't working properly back then, but eventually all of them got fixed, and I pretty much just enabled test backs with the slight tweaks over them. So the next thing was SDK, and I updated SDK to provide nonce in the data contract rate transition. Sam just explained it, what was the purpose of that. On the drive side, there was a little bug with the masternode reward shares data trigger. And also there are a few bugs with the GrowDB queries related to querying of the identity keys and getting proofs when we are requesting proofs for identities, data contracts, and documents all together in one query. Yeah, and the other little thing was update of the dashboard RPC to provide masternode operator payout address in the mn list div query. This is also done. Thank you very much. This is it from my side.
Thank you very much, Igor. Do you want to add anything, Sam?
No.
All right.
Thanks, Igor.
Thanks, Igor. Let's move forward with Paul.
Hello, guys. I am continuing to work on strategy tests in the platform terminal user interface. and it's really quite fleshed out at this point. In the last 2 weeks, I added creation and registration of random contracts. So now we have random documents, random contracts, contract updates, identity inserts, identity updates, withdrawals, and transfers. So almost everything. Yeah, and it's all working pretty well. I think the only thing that is not working very well, or that I want to improve, is the last bullet there, faster identity inserts, because right now it's only like basically for each identity insert state transition, we have to do an asset lock on core, and it's just single threaded right now. So I want to make it multi-threaded, and it's only utilizing one UTXO at a time from the wallet. So I want to basically make sure the wallet has enough UTXOs to do multiple at a time, and basically just make it faster, because the purpose is really to kind of stress test the network. So, and right now the identity inserts are slow. Besides that, like, I'm pretty happy with everything on it. We'll see if Sam and everyone else is. But I think it's pretty good. It has like all the functionalities, and yeah. So besides that, I fixed some errors. I added the basically proofs. So like when a state transition is submitted in a strategy test, we verify the proof. I think we're going to make this something that you can turn off if you want to, for the purpose of load testing. Thumbs up from Ivan. But yeah, Sam asked me to add that, so I did. I enabled credit withdrawals, and I broke testnet with it because testnet is on an old version, but it's working on the latest version of platform, which we're going to deploy to testnet in the next few days, I believe. And yeah, besides that, just fixing some bugs. And yeah, that's all.
Thank you very much, Paul. And with that, let's move on to the core team.
Before
Alright,
we start with core team, Pasta,
Yeah.
you just had to steal our thunder, huh?
Yes, I did.
Mhm.
All right. Well, thank you, Balash. Thank you, I guess, Sam. So yeah, the major development this week, we're very excited to announce that we've just released version 20.1. It was just pushed to GitHub about 45 seconds ago or so. And so you should have gotten notifications everywhere that you do. This is a minor version, but it's surprisingly big. You can take a look at the release notes that I've linked here. I'm not going to go over everything. There's not, it is a minor version. There's not going to be a ton of stuff that is like, wow, that's really incredibly interesting. But there's been a lot of fundamental work done that supports our V21 development. A lot of really important backports have been done. One of the major things that the community asked us to get done, and took a while. Latte spent a lot of time on it and did a good job, but getting a certificate authority issued code signing certificate probably cost us more in time than anything else, but we've got that done now. Version 20.1 is signed by this DigiCert, created certificate. So that was a major thing that the community asked us to do. Another thing that we've done now in V21 is HD wallets by default. No more do you have to back up the wallet.dat every month or so if you create a new wallet. Really important to specify this isn't retroactive. This is only new wallets going forward. You've been able to upgrade wallets to HD in the past. You still can, but honestly, I would probably recommend just creating a new wallet if you want to use an HD wallet. You're able to, put that seed in a safe or a safe deposit box or however you want to store your seed. Make sure your seed is safe, and then you know that all of the keys generated in that wallet in the future will be backed up from that. There's some other kind of minor Qt improvements. We added a discrete mode where you can hide the balances if you don't want the balances being shown. There's an option to close all of the wallets. You don't have to select every wallet individually, stuff like that. But low, the largest thing that we accomplished was Bitcoin backports. There is, even if you go to the release notes, there's a significant set of RPC changes. A lot of these were to support different platform stuff that they needed. There's a couple of things in our build system that got updated, but a lot more technical. Really a lot of backports. I should have put together some details on how many, but it might not seem like a huge version, but I think it was close to like 1,000 commits, maybe even more between 20.1 and 20.04. So I am always really excited when we have these incremental versions that we're able to release every, couple of months or so that, don't necessarily need to introduce a ton of major breaking features where everyone has to upgrade. This is an optional version, but it still includes some really cool stuff that we are very happy to ship and get out to people. So this is heavily recommended for NAS nodes. You don't have to upgrade. It is recommended. Having people upgrade also helps ensure that all of this stuff that we've introduced doesn't have issues in it. If there are issues, we'll release patch versions as needed. But all in all, very happy to release 20.1. Yeah, kind of hit the main points there. We are also continuing to move forward with V21 development now. We've branched off v20.1, and so now on develop we're able to merge in breaking changes. I'm okay, merging breaking changes now into develop. So actually that's a good notice to the other development teams here. Expect that, there will still be release notes as stuff happens, but expect that develop might be slightly more unstable now. Everything in 20.1 was non-breaking. There was absolutely nothing breaking. Now that we've branched it to v21, if you're using developer nightly, it could have breaking changes, so just be aware of that. But we're going to be able to start merging in stuff like BIP324, which Kitty Whiskers has been working on, and he's been doing a really good job, which is P2P encryption. That itself is not a breaking change, but there's some other stuff that we've been moving towards as well. So you can take a look at the other stuff there. I've kind of talked about it previously. You can also look at the Bitcoin backport progress in general. We're basically all the way up to version 21 is complete, and version 22 of Bitcoin is making really solid progress, as well as later versions. So, all right, I think we can probably move on to the next slide. So this is really not that useful of a slide. I wanted to keep it around because I want to track version 21 or version 20.1 as that has more adoption. There's really nothing to talk about here. So good job. You all upgraded to version 20 a long time ago. Do it again. So we did merge quite a bit of stuff in the last 2 weeks. A lot of the stuff is release related, updating man pages, adding the release notes, everything like that. But there's also quite a bit of backports. Feel free to look through this and take a look at the individual PRs if anything pops out to you or seems interesting. But yeah, that was the main thing that I wanted to announce, and happy to have delivered that. So I think we can move on from core and go over to mobile.
Indeed. Thank you very much. Let's move on to...
Great. Thanks, Basta. Yes, the first slide on Android, we kind of had a myriad of things, kind of all over the place. The priority was on dash spend and CoinJoin. We finished basically about half the stuff that we had planned there, and finished a few other touch-up things shortly after the sprint finished. But the Rust library work continues. Coinbase made some changes on their APIs. So we moved to a custom tab design or implementation. And we're changing the default purchase amount on Tauber. And slowly but surely continuing on some of the Maya implementation. So that's it for Android. On iOS, focus was mostly on Rust libraries, and CoinJoin will make the same default purchase amount change on Topper, but that's a lower priority. So that covers us for mobile. We're still having some discussions with the Apple Store on the last review. So we're waiting for that version to get approved on them. That's pretty much it.
Thank you very much.
Brian, who came up with the name Advanced Mangling System?
Not me.
It sounds like it was
I
a
won't throw anyone under the bus, but it was not me. So.
Okay, I think probably not a native English speaker, but that's interesting. Okay, I think I know what it is.
All right, shall we move to the questions? So I see one question with a Q prefix from Ryan. There is some support for DNS in Dash Core, but it's disabled, maybe from the Bitcoin days. Is DCG open to reviewing a PR to re-enable DNS for Dash Core so masternodes can register with an IP or domain name?
Yeah, so I can speak to this.
Yes.
Basically everything in Dash Core is network agnostic. We use DNS for seeds primarily. If you don't have any known peers, you generally will use DNS to try and find some. Although we also hard code a bunch of seeds into the client. But so yeah, we use DNS for that primarily. But you could connect to a node over P2P via a DNS domain name, I believe. There's nothing stopping you from doing that. You've always been able to do that. Same way you can access a node over Onion or I2P or IPv6 or IPv4. You can also use DNS. When it comes to master nodes, though, those are special. And we've never allowed anything other than IPv4 in masternode registration. IPv4 is really simply the most ubiquitous and versatile. It's kind of the most reliable. I feel like there's probably a lot of good reasons to require IPv4. It is something that, I think DCG is probably open to a discussion around it. But I, from my perspective, don't see any motivating factors to allow anything other than IPv4 at this point. I know, XKCD has really advocated for allowing people to register Onion addresses, but that requires that people use Tor in order to access masternodes. The purpose of masternodes is to be highly available and accessible, and the easiest way to do that is by having an IPv4 address hard-coded in the masternode list. So I don't know if anyone else wants to speak to that at all, but yeah, everything else in Dash Core is network agnostic. You can use a whole set of networking protocols, but not masternodes. We require IPv4 and always have for those.
Yeah, the thing that I wanted to add to that for Ryan, because Ryan asked the question, is why the question is DCG open to reviewing a PR to re-enable DNS for Dash Core? And the question makes me wonder why. Like first, we never disabled it, right? As pasta. I'm gonna guess that you mean in the deterministic masternode list. It's always been IPv4. But the real question, the thing that I'm wondering, and I'm having a hard time expressing myself, I guess it's late, is why? Why want that? Why would you want that? So maybe that's a follow-up question if you're there, Ryan.
Right, we have like 10, 15 seconds delay in the streaming, so we can wait for that. I don't
maybe
see any other. your question with a Q prefix, but I'm just going to read out with those without one. So what happened with the platform testnet? Any ETA on getting it back? And do we expect a chain wipe?
Answering Paul from R&D.
No, he already said he broke it by submitting a withdrawal, and that version was the one that we had on testnet was the old version. Normally, we should not run into such issues anymore. So we had disabled withdrawals and we had pushed to testnet, thinking, if I remember correctly, thinking that, well, okay, withdrawals will break the system, but we're not going to have them, right? I don't remember actually. It's hard to remember what even happened a week ago. So a few weeks ago, it's probably.
I'm not following since Friday. I mean,
we've been
processing.
Yeah, we've been working on very different things. But in terms of when we get it back up, we are going to merge in. Well, no, we were already merged in the code that we talked about today. We're going to deploy that on Uzo tonight or tomorrow. And we're going to just verify that it works there, and then we're going to deploy it on testnet as soon as possible shortly after. So I think this week. Yeah, I mean, I don't see why not.
If everything works.
Yeah, if everything works, but it already, well, it's shown to work. So it shouldn't, I mean, there can always be something, but right now it looks very promising for testnet this week with the new version.
Okay, I think we answered this, but yeah, let's just take a look at it. Will it be on mainnet before BTC halving, which is in April?
No. No, it will not be on mainnet before BTC halving. The process that we have to follow right now is that we are going to give out a version that, you know, is attackable. Like, people should try to break it. Community members, everybody, during probably a 1 month phase. And at that point, and during that period of time, we're going to deal with internal code reviews and probably work on the fees and the economic aspect of the system. For example, we have all the fees done, right? But we still haven't verified that, you know, certain operations are actually costing exactly what they should be costing. And we're gonna verify all of that. And there's gonna be some tweaking. Some operations will be a little bit more. And then once we have the release, it doesn't go to mainnet directly. We're gonna release. We're gonna have to ask Evo nodes to upgrade, and then it will be in the hands of the Evo node operators and master nodes actually to upgrade to the new version. So it's going to be a very exciting year for sure, and then very exciting next few months, and then after that, rest of year. Even when we release, there's a lot of exciting stuff coming. I mean, there's going to be activation of Dash Pay on mobile. There's going to be, yeah. It's very nice to see this finally. Well, I mean, it's getting better. We're not done. We're not done. Can't count our eggs before they hatch. But
there are some follow-up questions.
Mhm.
Will be there a wipe for platform testnet, or just the new version will make it live again?
Yeah, it will be a wipe. It's a new version with nonces. It's a breaking change.
Nonces were in the previous version, no? No, no, they were not. Okay, I'm sorry. Yeah, there'll be a new version. One wipe.
Thank you. TL clarifies or shares his or her thoughts. I think Ryan's question was related to be able to deploy other masternode services like hosting websites. Also maybe about zero SSL being the only way to get IP address. My guess is it's not a question. I don't know if you want to comment on that.
To be honest, I didn't get it.
I mean, right now you can associate a DNS address to any IP address, right?
Yes, that's for sure.
So
People other Western services like hosting
if you
websites. Yeah, I mean we're planning. I mean the whole idea of the platform that you can it's a development stack for your application, and it's hosts not just your data, but eventually and the your assets, I don't know, like CSS, HTML, and you can serve it. So it will be combined together with DPNS and resolved by the dash name. So that's what probably you're talking about, isn't it?
Maybe next week. I mean, in 2 weeks, we can have a follow-up or continue this discussion on Discord.
Yeah.
All right, thank you very much. We ran out of time. Thank you for the questions, the comments, and feedbacks. And see you in 2 weeks.